Okay, good day guys. In this video, we are going to focus on moments where I'll be explaining and showing you guys how to determine or how to convert from UDL load to a point load, as well as to determine the magnitude of a reaction using two methods, which are moments and sum of all the forces. So without wasting any time guys, let's take a quick look at our given question. This question is from one of the previous question papers, which is Mechanical Technology, November 2021, grade 12. So let's look at our diagram guys. We can see that we are given two reactions and 2-point load, which are 9,5 kilonewton and 4,5 kilonewton. And then lastly, we are given a UDL load. We've got a UDL load that acts on 5 meters, right? So let's look at our question. They want us to calculate the point load, right, representing the uniformly distributed load. So let's try and solve 8.1. Therefore 8.2.1 to find the point load, we say F equal to W multiplied by L, and we know that F is what? It's a force, and force can be measured in Newton or kilonewton, right? And then this one is UDL intensity guys. It's a UDL intensity, right? And then lastly, L is the length. L is the length where the UDL acts. Therefore, let's rewrite our equation. F equal to W multiplied by L, right? And then we've got UDL intensity is 16. And then we've got the length that the UDL acts on. It's what? It's 5. Therefore, 16 multiplied by 5. Let's plug it on the calculator. 16 multiplied by 5. It's 80. We get 80 kilonewton. That's F. So this will be the answer guys. This will be the answer for 8.2.1. We get 80 newton. So let me rewrite this answer here. 8.2.1 F equal to 80 newton. The reason why I'm writing it here is because I'm going to need this space. I need some space here. So let me erase everything. I'll only leave the answer guys for 8.2.1. Okay, so now let's look at 8.2.2. They want us to determine the magnitude of the reaction at point A, right? But before attempting this question, I would like us to do it, to redraw our diagram, right? Now that we have the point load instead of a UDL. So I would like us to redraw our diagram, right? So our diagram is going to be like this. right? It's a beam, therefore reaction at point A, reaction at point B. Don't mind my drawing, guys. And we've got a point load of 9.5 kilonewton, and we have another point load here which is 4.5 kilonewton, right? And then we are given that the distance from point A to point B is 10.25 meters. And then now what's left is to represent the point load of what? Of the UDL, right? On our diagram. So when we represent the point load of a UDL, right, we draw it at half of its original length. We draw it at half of its original length. What's the original length? The original length of the UDL is 5, right? It's this 5 meters. Then its half, it's going to be 2.5, right? Therefore, meaning it's gonna be half, right? Which is 80 kilonewton. So going to have this distance here as 2.5 meters and 2.5 meters, and together they make what? They make the size of the original length, right? So now that we have our diagram in a simpler form, we can do that. We can calculate the magnitude of the reaction at point A. So to calculate the magnitude of the reaction at point A, we simply say sum of the moments at point B, right? Let's take anti-clockwise as positive, equal to 0. Therefore, all the loads or forces that are going anti-clockwise, they are going to be positive. Then the ones that are going clockwise, they are going to be negative. So we've got RA. So this RA is going clockwise direction. It's going in clockwise direction, meaning it's going to be minus RA multiplied by, I'm sorry, multiplied by 10.25, right? And then we've got another load which is 9.5 kilonewton, but then this one is going in an anti-clockwise direction, right? Therefore plus 9.5 multiplied by 10.25. Again, we've got another load which is 80 kilonewton, and then it's going in an anti-clockwise direction, therefore it's positive 80 multiplied by, and then its distance is going to be 10.25 minus 2.5 which is 7.75. And then lastly, we've got another load going in an anti-clockwise direction, which is 4.5 multiplied by, and then it's going to be 10.25 minus 5, which is 5.25, equal to 0. And looking at And looking at what we have here, we can see that we only have one unknown, which is RA. But then since it's negative, let's take it to the other side so that it becomes positive. Therefore, this side I'm going to remain with 9.5 multiplied by 10.25 plus 80 times 7.75 plus 4.5 times 5.25 all equal to RA multiplied by 10.25. And then from here, it's just a matter of plugging everything into your calculator. But then I'll advise you guys to do it step by step. So let's check. 9.5 multiplied by 10.25. We get 97.38 rounded to the rounded to 2 decimal places. Then plus 80 times 7.75, we get 620. Then lastly, plus 4.5 multiplied by 5.25, we get 23.6 rounded to 2 decimal places. Therefore, all equal to RA multiplied by 10.25. Therefore, let's add these three. It's 97.38 plus 620 plus 23.63. We get 741.01 all equal to RA multiplied by 10.25, and then we divide by 10.25, we divide by 10.25. Forgive me guys, flu is killing me. It's really doing its job. It's killing me. Okay, here we can see that 10.25 is gonna get rid of 10.25, right? Therefore, we are left with RA. Sorry, let me use black pen. We are left with RA, which is equal to we say 741.01 divided by 10.25, and we get 72.29 Newton, rounded to 2 decimal places. So this will be our answer, guys. This will be our answer for 8.2.2. So let me rewrite it here. 8.2.2, we say RA equal to 72.29 kilonewton. It's kilonewton, guys. It's kilonewton. Forgive me. It's kilonewton, guys. Therefore, now we are left with 8.2.3. So likewise, I'm going to erase this part because I need this space. I need this space, guys. Okay, let's carry on. So 8.2.3, they want us to determine the magnitude of the reaction at support B, right? There are two ways to do it. One, we can use the same procedure, and two, we can do what? We can use sum of all the forces. So I'm going to show you both method, guys. Let's start with this one, sum of, okay, sorry, let me use the pattern. Sum of the moment, right? But this time around at point A, taking clockwise positive equal to 0. Equal to 0. Therefore, we've got RP. RP is going anti-clockwise. Therefore, minus RB multiplied by 10. Multiplied by 10. Multiplied by 10.25, and then plus 4.5 multiplied by 5, then plus 80 multiplied by 2.5, all equal to 0. And again, we can see that we only have one unknown, which is RP, negative RP. So to make things easy for us, let's take it to the other side. So this side going to remain with 4.5 multiplied by 5 plus 80 multiplied by 2.5, all equal to RB multiplied by 10.25. Therefore, let's work it step by step. 4.5 multiplied by 5 is 22.5. Then plus 80 multiplied by 2.5. 80 multiplied by 2.5. It's 200. It's 200, all equal to RB multiplied by 10.25. Therefore, let's add these two. When we add them, we get 2 2.5, all equal to RB multiplied by 10.25. Then from here we can divide by 10.25. We divide by 10.25. And we can see that 10.25 is going to get rid of 10.25, and we remain with what? RB. RB equal to 222.5 divided by 10.25. We get 21.71 kilonewton, rounded to the nearest 2, guys. So this will be the answer for 8.2.3. So let me write it here. 8.2.3 RB equal to 21.71 kilonewton. Right? So we are done solving these questions, guys. But then remember, I told you that there are two ways or two methods that we can use to get what? RB. So let me quickly show you the second method. It's easy and straightforward. So let me erase this part quickly. Let me erase this part quickly, guys. Okay. So the other method I said is sum of all the forces, right? So in this case, we're going to say, let me use black pen, sorry. In this case, we are going to say sum of all the forces, right, that are going up, positive, equal to sum of all the forces that are going down, positive. Right? What are the forces that are going up? The forces that are going up is RA, and we already have it, right? We have it as 72.29, right? Plus, we don't have RB. Remember, it's the one that we are looking for. And the answer that we get, guys, should be the same as the answer that we got when we used the other method. So we say RB then equal to, and then this side we said sum of all the forces that are going down, which we have 9.5 plus 80 plus 4.5, right? Therefore, let's take this 72.29 to the other side so that our RB remains as the subject of the formula. Therefore, RB equal to 9.5 plus 80 plus 4.5, then minus 72.29, and then from here let's put everything into the calculator. 9.5 plus 4, sorry, plus 80 plus 4.5, then minus 72.29. We get 21 point, we get 21, guys, 21.71 kilonewton. That's RB, guys. So we got the same answer, guys. So when you get your first reaction, to get the second reaction, you can either use a moment method or sum of all the forces method, right? You'll get same answers. So that's it for this problem, guys. I'll see you in the next video. Thank you.